This is Dwayne at RealFixesRealFast.com. Today we're working on a 99 Mercury Grand Marquis 4.6 engine. The people brought it in and said it seems like it's got a mist to it. That's the only complaint. We opened the hood and did a preliminary check. Now the history on this is not too long ago we did change the spark plugs and did a tune-up on it. But now it's back, it's got a little misfire. The check engine light is not on, but as you said here, you can feel that mist, and it's ignition mist. I went out and drove it, and as we drove it, when you accelerate and stomp on it, you can feel that mist. It's just feels like an ignition mist. We bring it back into the shop, I'm going to start checking it out. Now we're going to use the Verus. We've already scanned it for codes, and there's no codes stored in the memory. Whenever that happens and I can clearly feel a misfire, and I got a Ford product, I really want to go to the mode 6. So we're going to go to the engine. I'm going to go down to generic functions, and after generic functions I'm going to go down to mode 6. Once the mode 6 comes up, you'll see all the different test IDs. For the misfire counters in a Ford, you have to go to generic 06 and test ID 53. Now once at 53, it'll bring up all the cylinders. Now if you look over here, there's cylinder 1, 2, 3, 4, 5, 6, 7, and as we scroll down you can see 8. Now it also shows 9 and 10, which we ignore because this is not a 10 cylinder. So we're going to go back up here and you'll notice 1 through 6, the value is 0, no misfires. But on number 7 there's 1260. Number 8 there's 0 again. So the computer's picking up some of these misfires. Now my personal feeling is there's a whole lot more misfires than 1260. But again, my experience is Ford usually won't turn on the check engine light till there's about 14,000 misfires or more. But anyway, so we're going to go look at plug number 7, see what the problem is there. Now the good thing about the Verus, the way it's set up too, that I like, is we can go ahead and leave the scanner plugged in, but I want to go around to the engine compartment. But I got a long enough cord, I can leave the scanner plugged in, and we can go up here and start looking at the engines. Now what I want to do in this case, I'm suspecting that it may be the coil. The reason is, I got no reason to believe it's not, or that it is, but coils are pretty commonly a problem on it. We took the spark plug out, and it actually looked pretty good. As I said, we replaced them not long ago, but anytime I take a spark plug out, I'm going to put a new spark plug back in it. So we've got a new spark plug in it. Next thing to check is the coil. But how do we check the coil? There's a lot of guys that have just a whole box full of known good parts. When they got a misfire, they might just change the coil. If that fixed it, they say, well, you had a bad coil. And they did, and you actually fixed it, but you don't know why. Probably one of the most common ways is to take the suspect coil out, swap it with another one, look at your scanner and see if the misfires followed the bad coil. If they did, you'll probably change the coil and you'll fix it, but you really won't know why, and you won't be able to verify it. Now if you have a lab scope, using the scanner and the lab scope, we can actually show you how to identify the problem, fix the problem, and have total confidence when you talk to your customer about what was happening and what you had to do to fix it. Now this engine has the coil on plug style. You can see the coils right there. Now get out your wiring diagram and you'll see that all the coils have a red wire. That's the power wire. They'll have a different colored wire on the ground side because the computer supplies the ground. So we're going to look at the ground wire, or the colored wire, on number 7. Now as I said, we took the plug out, put a new plug in, put the coil back in. But we're going to look at this coil. We're going to use current ramping, so we're going to use the negative side. Now you have to use a low amp current probe. Switch it up to the sine wave side, the 20 amp. And we're going to place it around the negative wire. Under component testing, I'm going to scroll down and go down to ignition testing. There you can get component information here, tells you about it, tells you your firing order and everything. We're going to go down to primary tests. And I'm going to go down to current ramping. We could do key on, engine cranking, resistance, signature, but I'm going to do current ramping. Now just here's a point, if you're going to do resistance or signature, you're going to be using a voltmeter attachment, not a low amp current probe. But on coil testing you want to use a current ramp, so you have to use the current probe. It'll tell you right here exactly how to set it up. You can scroll down here for more information. This is the type of signal we're going to be looking for right in here. Now I'm going to view the meter. There's our meter. Now to check the coil, we're going to use a low amp current probe. We need to plug it into the back. The ground always goes into the ground connection or the common. Now this we're going to use, this is a 4-channel scope. The channels are color coded. We're going to use the yellow channel. Since we're plugged into the yellow channel, we're going to use the yellow pattern on the front. Now you can see our pattern. We got yellow, green, blue, and red. That's for the colors that were back here. We're plugged into yellow. We're going to use the yellow. We're going to look at the yellow line. We're going to hook our current probe around the negative wire on the coil and start the car. Now you don't see anything. Well, don't get confused. You've got to learn your scope. You can see something's going on there, but our trigger is way up here. So let's slide our trigger down. Now we'll slide this thing up. You have to get it to where you can see it.
You got your sweep.
Yeah. Now you can see there's something there, but you can't tell what it is. This is electrical current, so it does have a polarity to it. If it's that way, then unhook it, turn it around, and put it back on the other way. And now you can see on our scope we've got a pattern and it's going up. So you have to have the correct polarity. If you hook up your scope and nothing's right, nothing's making sense, start checking your settings. Now, I can't see the peaks, so I'm going to go over here and drag this down a little bit where I can see the peaks. Now, as you look at the coil, we're triggering right here. The coil is off, 0 volts, comes over and the coil turns on and goes up and turns off. Now, actually, I want to spread that out. So I'm going to go up to my sweep again. Let's go down to 10 milliseconds. Go to my sweep again and go down to 5 milliseconds. And now it spreads it way out and you can see it. Now, is this a good pattern or a bad pattern? When you're looking at the coil turns on, energizes, turns off, and then these are repetitive patterns. They're normal in this type of ignition system. But you can see the baseline is not staying stable after the fire. Now what do I mean by that? Let's switch and go to a good plug and compare it. So we're going to come off of the coil we suspect and go to a known good coil. We're going to leave it around there. And now we're looking at this coil, the same thing. Okay, so as you see, the coil turns on, energizes, powers up, and turns off. But the baseline stays level the whole time. Now again, this is on the good coil. Now let's go back to the bad coil. Let's show this. We're going to go back to the bad coil. Now if you look at this, the baseline after the coil turns off drops out sometimes. Now I'm going to emphasize this a little bit more by brake torquing it or power braking it. So let me raise this up here a little bit. Now watch this signal when I brake torque it.
Yeah, it's dropping all the way down in negatives.
Okay, let's compare that now. Let's go back to our good coil. And I'm going to brake torque this one.
Yeah. Yeah, it ain't dropping. It's flatlined after the fire.
So you can see now we're on a good coil. Our coil is energizing up. Now if you don't want this to jump around a little bit, you can raise the trigger up to a little bit of higher point on the peak and it'll trigger off this higher part. It'll keep it from jumping down. But the baseline stayed level on the good coil, and on the bad coil it had an unstable baseline. Too much resistance in that coil. So what we're going to do now is change the coil number 7, and then look at the scope. Now, fortunately, these coils are pretty easy to change. We just loosen the strap, take these out, take this off. You can see the coil right there. We unconnect it. There's a screw holding it down. We've actually even already taken that off. Got a new coil. Put that in there real good and snug. Plug it back in. Put our tubes back in. Tighten down our breather box. Breather tube. Now, we're going to take our current probe. Now if you have a current probe like mine that has a fail-safe in it, it'll turn off to be a battery saver. So sometimes you turn it on, you got no signal. Always turn it off and then back up on until your light lights up. I've many times wondered where'd my signal go, and I come back and find out the current ramp is turned off. Now we start it. We got our coil signal on there. Okay. Now we're on the new replacement coil. I'm going to go brake torque this. Okay, now you can see we got the new coil, we got a good stable baseline, and our misfire is gone. I know on video you can't feel that mist, but the misfire is gone. So get familiar with your scope, know how everything works. You can actually move it up higher, down. Sometime if you hook everything up and you don't see anything, maybe your trigger's not right. Now my scope, I can actually move my trigger with my stylus. I can move it up here. The trigger's right at the very tip. If I move it up even higher, you can't see anything because the trigger's too high. The trigger is the point at which the scope is going to start recording. The trigger's so high, there's nothing going up that high. If I bring the trigger down, it'll pick up the signal and start recording. Now some scopes, the ones I've had in the past, they'll be like a thumb wheel or an arrow over here. You can move the trigger up and down that way. But somehow you'll be able to control your trigger. So get familiar with your scope and you'll be able to diagnose better.